I'm not attending for. Who is this fellow? He didn't share any roll number. Neither I have found his roll number. Anybody knows his name? Mogili Paka Naresh Kumar. Sounds to be good. I mean, Telugu. Anybody knows about him? In the class, anybody knows about him?
No, ma'am.
So I have to find out. Like he's not giving his roll number or whatever. Fine. Okay. So yesterday's postings. Let me see how many of you have done or what. Anybody has done anything interesting in that? Anything interesting in the last this one?
Ma'am, there in that question for even parity check.
Yeah, that is fine.
There,
I have given another one. I have posted one problem 3. Like wait, let me tell you. There is a problem particularly posted for you, and then somebody has downloaded also. Just a second, it's opening. There's a power cut now. That's why this all internet everything is gone on. Okay, design a logic circuit which has 3 inputs A, B, C, and the output of the gate goes low. And when the A is high and B and C are different. Did you do this? You people have not done this? Nobody has posted. That's what I was wondering. Nobody has posted.
Yes, ma'am.
Ma'am, yes, ma'am.
Yes, ma'am, posted.
Yes, ma'am.
Someone has posted. Okay. So did you understand this question?
Yes, ma'am.
What is that? Like it can be analyzed.
Ma'am, I can repeat the question.
Okay, I'll share the question. What's the big deal? I can share the question. I think it's there already in the assignment.
Ma'am, question number 2.
No. See, I'm sharing. See, it's simple one. Design a logic circuit with 3 inputs. Okay. Then A, B, C, and output that goes low. Okay, so that means one output is there. Okay, so what we can get from that is right. So they are telling that when it should be low. If A is high and B and C are different, that means A is high and B and C are different means 1, 0, 1, 1, 1, 0 combination. That's it. Is that correct?
Yes, ma'am.
Yeah, only 3 combinations you will get, right? So now what about the second? Design a circuit to pass signal A only when B is high and C is low. The output must be low when A is not being passed. Okay, what do you understand by this?
Ma'am, when B is 1 and C is 0, A will be 1 and output will be 1.
Okay, then?
And rest all will be 0.
Okay. So everybody agrees to that?
Yes, ma'am.
Okay, what about 3? Third question.
Ma'am, not
Which
not
logic
NAND
gate
nor.
produces say one output in a disabled state? It's not only not, we can say not and also.
Not NAND nor XNOR.
Oh, why so? X nor Y?
Ma'am, because if 2 inputs are there and both are disabled means 0, then the gate will produce 1.
Okay.
Ma'am, actually there's a bit confusion that it is only 1 input or we can take 2
Yeah,
inputs.
that is what even I was asking. See, now since this is a question which is having a broad spectrum, I mean spectrum, because it is not preferably only 2 inputs or 1 input, nothing is mentioned. So it's up to you. Since why did you get XOR? By the way, who is telling that? Who has told that?
Ma'am, me.
Me means what?
Samay.
Okay, Samay. Yeah, Samay. Question comes like since it is not mentioned, it is specifically this many inputs. We can take any number of inputs.
Okay, ma'am.
Right. So 1, 2. If it is applicable for 1 and 2, that is fine. If you want, you can still extend.
Okay, ma'am.
Okay. Right. Then what about the next one? Which logic gates pass the inverse of an input signal when they are enabled? That means when inputs are high, the output should be inverse of that. That's what, no?
Yes, ma'am.
Yeah. So what are the ways?
Ma'am, for one input not, for two inputs and
Hmm.
NAND,
Okay.
for three NAND and NOR also.
Nor also can come. Yes. Nor also
Yes,
can
ma'am.
come. Yes. Then what else? Only Samay is talking. What about others? Others are agreeing or you are disagreeing? No reaction whatsoever. Amrit? Amrit means he or she. Not there. Amrit? No idea. Ankit?
Hello.
Abhijit.
Hello. Yes, ma'am.
Yes. Abhijit is there. Then Amrit is not there.
Hello. Hello, ma'am.
Why? He has only logged in. Hmm? Dhruv?
Yes, ma'am.
Okay, you're there. Okay. Good. Right. So you people have done that one. Okay. Now, what next we will discuss? In combinational circuit, what else we can discuss? Just out of curiosity, I'm asking. Like there are no regular topics. We can add so many topics. Like combinational is a ocean. So what else you wanted to discuss in that? Can we discuss about? You have an idea?
What, ma'am?
Multiplexer. You have any
Ma'am,
idea of that?
yes, ma'am. In the basic course, we
Oh,
have
in the
that.
basic mode. Okay, no issues, no issues. I am here to elaborate that one. Okay, so my question comes here very simple. Prior to require, first we should know why the requirement is there for the multiplex. Then afterwards we can go for the design of that. Correct? Okay.
Yes,
Now,
ma'am.
now let us consider. Okay, I'll stop sharing and then go back to the screen. Okay, let us consider a requirement has come. Okay, like I have
Ma'am, you are muted. You are muted.
huh? Right. Okay. Consider a situation. Okay, scenario like this. Right. What is that? We have four inputs. Okay. So now in the four inputs, right? And I want all these inputs to appear at the output. Okay. All these inputs should be appear at the output, but not all at a time. Okay. Just a second. A small change. Only one output I have. Okay. All these four should appear, but not at a time. I want them to take turns. You are understanding my point? Think, I have four inputs to a black box and my output should be having every input but one after another. Can I have a control like this? Otherwise, I'll give a practical example. Before this mobile, again I muted? No, no? Why no response? Okay. So before your mobile communication has come, earlier there was a trunk call system. That means a call will be booked manually at the center. One fellow will be like we have 4-5 requests, and every time one request will be handled by the telephone operator, and that fellow only line will be given, and after that another fellow will be prioritized, another. That means there is a queuing system. You're understanding?
Yes, ma'am.
Right. So visualize such type of system. That means one operator is there, right? And 5 requests are there. And then the operator will take turns to satisfy each request. Then connect them. So the operator job is what? To memorize or to take care of the connections. Correct? So that means every time only one connection is allowed. Rest of the people will be in waiting. So can I relate that with this?
Yes, ma'am.
Right. So now think carefully. So operator I cannot fix in the black box. So can I have an operation or can I have a self-designed automated version which can take many inputs and give only one output at a time? That means I will have a selection among the inputs, then afterwards pass that on to the output. Is that clear?
Yes, ma'am.
I will select. So that means I want to have a control of the inputs through selectors. Then afterwards send them to this one, channelize them to the output. Again and again I am telling. So such type of device do exist, which we will call that as multiplexer. In short, it is called MUX. This one. So this is a combinational circuit. In fact, it's not a device. It is a combinational circuit for itself, right? Which allows many inputs, right? And with the help of select lines or selected inputs, we will take one output to the end. Like otherwise, we will allow one output. Is that clear? Should I repeat again?
Yes, ma'am.
Yes. So a multiplexer is a combinational circuit which will take many inputs, right, and select among the inputs to channelize one output at an instant. Right, that is what called a multiplexer. Now, since I have mentioned there is a select line also which is acting as a one of the inputs, so we have to understand like how many regular ones are there and how many select lines should be there. I should have a link among that. Then only I can take it to the output. Now, for example, if I have two select lines, right? Now see, we are in the binary systems now. So if I have two select lines, considering two select lines. So selector 1, selector 2. Okay, so these two for different combinations of that can definitely select 4. Did you understand? That means S1, S2 is there. I have different combinations for this and each time input 1, input 2, input 3, input 4. This is input number, not a decimal number. Can I use this option? That means when I manually, that means I will put some automation. Let us consider I have two switches. When 0, 0 is there, whatever input is there, that will be channelized to the output. Do you agree? Because I have framed like that. Do you agree that?
Yes, ma'am.
Right.
Yes,
Now,
Yes, ma'am.
whenever 0, 1 is there, 0, 1 is there, the input 2 is channelized to the output. Then 1, 0 is there, 1, 0 is there, the input 3 is channelized this side. Whenever 1, 1 is there, the input 4 is channelized. That means I am creating some connections between these two and the original inputs so that the output can be according to our interest. Is that correct? So for that, now consider if I have 3 select lines. Right? Now S1, S2, S3, 3 are available, but I have only 4 inputs. So will that suffice my duty, like suffice my work? That means S1, S2, S3. How many it can select? How many
8
numbers we
numbers.
can? Yeah, 3. No, since there are
8.
3, 8
8.
combinations it can get. Yes, but unfortunately I have only 4. So I can take a calculation. Now just see here. If n select lines are there, it will take 2 power n inputs and then give one output. Is that correct? If n select lines are there, 2 port n inputs can be controlled and one output at a time can be taken. Is that okay?
Yes, ma'am.
Right. So that's why the size, we will normally say size of this mux will be n by 2 port n cross 1, where n indicates the number of select lines and 2 port n will be the inputs and 1 is the output. For some books, they will not mention this one. Directly they will write 2 power n by 1. So n already exists there. We can understand how many select lines, how many inputs are there, one output is there. Always. Is that clear? Right? So now this multiplexer is a simple circuit. Now just consider. Okay, I'll try to open up this circuit. Now this is output. Right. Now how I will draw the select lines? Right? These are available. Okay, it's not also is available, this is also available, right? Input not 1, input 2, input 3. So I am trying to make this one. Now how I should do the connection? Which gates are supposed to be connected? Please think carefully. Notation I have changed. This is two numbers only. I only have changed the notation, not 1. 0, 1, S0, S1 instead of S1, S2. Okay, then afterwards inputs I have clearly mentioned not as 1, 2, 3, 4, as I0, I1, I2, I3. Easy?
Ma'am, please tilt the camera a little downwards.
Yeah. Oh, I'm writing more down, I think, right?
Yes, ma'am.
Is it fine?
Okay, ma'am.
Right. So now, what exactly happens here? What do you think how the select line should be attached with this? Can I use the AND combination?
And get.
That is what. Now see, this has to be perfectly chosen. See, I know. Now clearly open the internal analysis. That means I naught is coming, right? Then S naught, S1 combination should allow that to go, right? So should allow that to go means what gate I should use? I will use an AND gate, or I should use the OR gate, or I should do what?
Or get, I think.
That's I don't know what gate I should do. First of all, this is more important. I have just drawn an AND gate, but what is that one? What gate I should use? This is the question.
Or
Which
get.
gate I should use?
And with input, we should use and get.
See, input is a separate one. Either 1 or 0 is coming. It is on its flow, right? These two should come and then take that input and put it to the output. So what should be the gate collection? What should be there?
And get.
It should be AND. Why? Why only AND? That's what. Now let's start a discussion because it's very important. Everybody can use. Yeah, please go ahead.
Ma'am, I think it will be an OR gate because if we want to put a combination like our I naught input I naught will go to output, then for allowing I naught we should provide an OR gate.
For allowing I naught means in the sense what?
For selecting I naught, we can say.
Ma'am, if we will use AND gate, then we will assume both the other inputs as 1, and if we will use OR gate, we will assume both the inputs as 0.
See how you can, just a second. You cannot assume the inputs, please. Inputs are like consider apples, oranges, something.
No, means I'm saying if we want to pass the input as only I naught,
Yeah.
only I naught will be processed. Then we will take the other inputs as 1 for AND gate.
Yes. See, the other input should not be considered at all, should not be taken into consideration.
Okay, ma'am.
That's what I'm telling. One input at a time. So again, please try to understand. Again, try to understand. Now wait a minute. Now wait a minute. So in order to open this wizard, we will again try to consider I have already fixed. Okay. Now what is that? I wanted to fix S0, S1, Y. If this is 0, this will be I0. Okay, this is fixed, right? In order to draw this one, blindly I am trying to draw. Okay, Y is already given. So, now what is happening? I0 should go. Right from this. Okay. Then Y can come. Just see. I1 is there. I1 when it comes 0 and 1. So, what is this? Just follow this. Can I take like this? Did you understand? See the notches. This one is coming. This is a notch. Okay. Can I use the AND gate combination and whether this truth table will work or not? Similarly, I2. I2 is what? Is 1, 0. So who is 1? S0 is 1. This is okay. Then similarly, I3. Try to analyze this. So this is not. I mean, this is a notch, so that you can see the line and then understand from where the signal is going. Okay, because it is multiple. Now, is this truth table working out here? If I use this, I am not telling this is the circuit. If I use this circuit for this truth table, will it work? Give your comments.
Yes, ma'am.
Is it working?
Yes, ma'am.
Right? So, what is there? These inputs are controlling this and this is coming out. Yes or not? This is what the multiplexer, what I was trying to tell you. Please try to understand. Question comes because selectors are also part of the inputs. Right? Finally, Y is the output. So there I am using a OR gate. So S0 S1 is 0 0. I0 only has to be gone, and this side or this particular stuff, this OR gate will receive only the signal from I0. Is that correct?
Yes, ma'am.
Yes. Now think of an alternative. Now this is not the final one. If you people agree only, then only I can tell you. This is what the functional table of a multiplexer. This is what I was telling about a multiplexer. Right? So this is 2 power 2 by 1. This is the size of it. Okay, this is what the functional table. That means the selectors will select an input and then send it. This is the open up of that. If you don't agree that, then I cannot proceed. So think hard. If you have any doubts in that, you can ask also. Right, not only this, if any problem in that one, if at all you want to rework in any manner, you can form another circuit also and can do. No issues. And if anybody is having an alternative, please try to explain me and then you can post it and we can decide whether it's fine or not. See, if you have an alternate one, please try to post me. Yes, no postings. People have done anything? Yes,
Yes,
ma'am. Please tell me. Yeah, you are not in there. Nobody is discussing also. You have any alternative for this? Yes. Yeah, go ahead. Samay, you are telling something.
No, ma'am. We were just analyzing this, and it seems to be
Yeah,
correct.
see, this is not the final one. We can always have different versions. But a multiplexer duty is to take the input to the output. So this is the functional table of that. So is this circuit doing that option or not? That's what I was asking.
Yes, ma'am.
Like,
It was.
okay, now otherwise another one, another simple one I am taking. Okay, I am taking just an input. Okay, so and I am telling that, okay, I have an input, I have an input. Okay, I have an X. Right, now hold on. This is output. Okay, these are all different. Now just see, my X is the controlling factor. If X is 1, okay, I naught will proceed. If X is 0, I1 will proceed. Is it working out?
Yes, ma'am.
So this is what a multiplexer is. I have a choice through X to allow one of the input. Is that correct?
Yes, ma'am.
You understood this or not? This is what a multiplexer is. A multiplexer is nothing but a combinational circuit where we will have a choice to allow the inputs, but inside it is opened up like this. Right. So that's what I think this will make it very simple. This is the second method. Okay. This one is our level. That means I will write increase a small diagram. Something like this. I have two inputs, I0, I1. I have a selector X and I will get an output Y. This is my marks. Is that correct?
Yes,
X
ma'am.
decides which to come out. Is that correct or not?
Yes, ma'am.
Yeah. So now, if at all we want to create a higher end multiplexer, what all we should follow in that? What all the rules? First thing is a functional table has to be followed. Is that correct?
Yes, ma'am.
Yes. Then afterwards, once the functional table is there, then we will open up and then take.
Ma'am, no audio output.
I'm so sorry, ma'am. There is some. See, if at all you are muting me, okay, you will be at lose. Right? I'll cover the course. That's not an issue. I'll say that this is over. Okay, you are able to understand the analysis of a multiplexer, the function of a multiplexer.
Yes, ma'am. Yes, ma'am.
Okay. Right. So we will not work out any problems in this now, right now, because first we should understand the original things behind it. Okay, just a second. I'll just try to give you one small problem. So here what I was trying to tell is, where to be used is the next option. Okay. Okay. Now I want the elevator to be designed. Now this is another question I'm trying to do. Okay. So how I will pose the question? Right. Now portion wise I will post. Okay. This is my question. Right. So now the circuit figure, everything I am keeping it in secret. Right now I am not disclosing it. Otherwise I can give that also. No problem. Just a second. So this one, first go through this. It's only a portion of the question. I'm not giving the total one. You're able to see or not?
Yes, ma'am.
Okay.
Yes,
Now,
ma'am.
yes. I will now. That is the question, but it is only halfway through. Right? I'll give you the full question here. This is M. M. Okay, you have read that? Then you have a look at this diagram. Okay. Have a look at this diagram. This is what I was trying to tell you. Right. What's the question? Your question is, you have to design an elevator circuit that controls an elevator door. Okay, in a 3-story building. Please try to understand. Okay, and the circuit is in the figure like what I have given. It is like that. You have M, F1, F2, F3. That means 4 inputs are there. Okay, when M is the logic signal that indicates when the elevator is moving. M is equal to 1 means the elevator is stopped. Is that clear? M is the logical signal that indicates when the elevator is moving. Okay, so you can assign M equal to 1 or M equal to 0 for moving or stop. That is up to you. Okay?
Yes, ma'am.
Okay.
Yeah, that is up to you. I am not mentioning that. F1, F2, F3 means are the flows. Okay, normal flows signals. Okay, normal flows. Right? That are normally, they will be low and then they will go high when the elevator is positioned at the level at that particular. You know that, right? Whenever it reaches the floor, it will glow. Is that correct?
Yes, ma'am.
So that is up to you. That also you decide. Okay. So for example, when the elevator is lined up at a level with the second floor, that means F2 should be 1 and F1, F3 should be 0. That is easy, no? And the circuit output is to be open the signal. You are understanding that?
Yes, ma'am.
Right. So now you have to design an elevator circuit that will open up. Okay, clearly understand. It's not a simple task. It is, first you have to understand here carefully. You have a signal M, you have floors F1, F2, F3, and your output is you have to open. Right? M clearly is moving or stopped. Assign anything. We have already 2 values, 1 and 0. It's up to you to assign. Right? If you are assigning 1 is for moving and 0 will be for stop. Is that correct?
Yes, ma'am.
Right. So floor 1, 2, and 3. Right. So when we reach the floor means that particular one will be high and the output should open. And it should be moving or stopped. That is up to you to decide. You're able to understand now?
Yes, ma'am.
Yes, this is an elevator circuit, a real-time application. See, different Otis, the Johnsons, so many elevator circuits are there. Everybody has their own logic behind it. Now, I want you guys to have your own logic. This is the minimum requirement I want. If you want some additional ones, you can tell me also. So, my requirement is I should know about moving or stop. I should know which floors I am heading to, and my door should open. Right. So, you give me the outputs nicely explained, like what operation you are performing. It's a very tricky question. Please try to understand. You should have your own thoughts. I don't think you should be giving the same answer. Everybody will not get definitely the same answer. Yes. You're understanding the question or not? Draw the circuit. This circuit will do.
Can you ask the question again?
See, question is like this only. I have been given a circuit. Just see, it is the elevator circuit. Okay, so you want me to share the circuit? I will share that.
The question.
Yeah, that's what question I have. It is in the form of a figure. See, in order to understand this, what question is what? Design elevator circuit. That's it. There is nothing much. See, I want an elevator circuit to be designed. That's it. There are 3 floors. Moving or stop should be controlled by this. Then afterwards, the floors lined up. They should be lined up like this. Like if at all it is at the first floor, definitely F1 only will be high. F2, F3 won't be high. That will be ridiculous, no? Because lift is at the position F1. Definitely these won't be working out. Is that correct? Yes or not?
Yes, ma'am.
Yeah, so that's what question is. I want a design elevator circuit for a 3-storied building. That's what. So it's up to you. You can put your own constraints and you can give me the answers. Right. Then afterwards, the analysis of multiplexer. Please try to remember. I will discuss in the next class about this applications of multiplexer. If any inputs are there now itself, you can tell me. Like we can discuss also, if you want, about this elevator circuit.
Ma'am, I have a doubt.
Yeah, go ahead.
Ma'am, when more than one like F1, F2, F3 are there, when more than one are like one, we can say one, then like what to do in that case? Like we'll ignore that.
Wait. You are designing a practical situation. Can there be more than one? Lift
No.
is moving means only one lift, no? Either
Yes,
it has to touch, that's what I was saying. It has to touch floor 1, floor 2, floor 3. How it can be more than one? It is a wrong question. I mean wrong. It is wrong. Not possible. No? Practically think. That's what. Digital is for practical applications. So we cannot violate.
Okay, ma'am. Okay.
That's it. Now go ahead. Anybody else?
Ma'am, when the lift is stopped and means all are 0 and only F1 is 1, then only it will open. And when all are 0 and F2 will be 1, then it will open. and when all are 0 and F3 will be 1, then the lift will open. So we
Okay.
will
So
design a circuit where
you are designing a circuit, right? Okay.
yeah,
So that means all 000 positioning means nothing is there. What it is doing then?
no, means only one is 1, means at a time only F1 is 1, and in the second case only F2 is 1, and in the third case only F3 is 1.
That I was telling, no, that is possibility is there, but all together ones are impossible.
No, together one is impossible. So we will design a circuit where M will only be when the door will open only when M is 0, and only one of F1, F2, and F3 will be 1.
Yeah, you can.
Then,
Suppose
Yes,
ma'am,
ma'am. Like,
I've sent a diagram, man.
you send it like this and check. Very slow internet, very slow today. Everybody seeing? I don't know. You have sent a diagram, but I didn't get no.
ma'am, I've sent a table, like the truth table.
That's what I am not able to check out. Yeah, Mrunal. Is it Mrunal? Oh, Abhijit.
Yes, ma'am, Avijit Naik.
You have sent it to player. Okay. Yes. Okay. What is the meaning of the cross?
Ma'am, like we'll ignore that. Like, don't cares. Like, we'll ignore that because, as you said, it's like practical question. So whenever
It's a
there are
practical
two,
question. That is
yes,
not
ma'am.
possible.
Yes,
Oh,
ma'am.
good.
So whenever two floors are activated, so we'll like ignore that case.
Yes, yes. Very good, very good. So your choices like I will ignore such type of impractical situations, right?
Yes, yes, ma'am.
Okay, so Samay is telling something else. Like this is what inputs I want. Otherwise, the class will be again already boring and much more boring. Wow. What Samay has given a circuit diagram, he has only 3 options. Okay. Okay. So Samay universe is what? Like what is the output like here? Because it is halfway through.
No, then we'll make a OR gate and pass.
In that case, you just see. If m is equal to 1 or m is equal to 0, what exactly? M is equal to the single line is there. Now, where do you want to connect that?
No, when
That
M is
is
equal to ma'am, when M is equal to 1, that means when the lift is moving, we need not open the gate. So it will not happen. We will open the gate only when the lift is stopped.
Is it so? See, Abhijit is very explanatory, self-explanatory, right? Hey, where is Abhijit posting on?
Ma'am, it's there. Ma'am, it's there.
I can't see. Yeah, it's there. Okay. This Abhijit had given what when m is equal to 1. What is your m control? Ma? Can you just tell me m control is what, Abhijit?
Ma'am, that when the lift is moving, so we'll not highlight any output. But as you said, there can be no like more than one from F1, F2, F3. So whenever there is a one for M and more than one in F1, F2, and F3, we'll ignore that. But when there is only one output from F1, F2, F3, but there is one, the M is equal to 1, the output will
Okay.
be 0.
Okay. So to be crisp, what he told is first of all, moving condition output will be not open. Okay. Again in that there is another violation. If 2 floors are highlighted, that is also a don't care condition you have to consider. Yes.
Yes, ma'am. Yes, ma'am.
That's it. So now Samay also has done the same way, but Samay is telling that if it is 0, where is the one condition means he has not shown in the truth table, maybe in the diagram he could have shown, right? Samay you have told 0 means it will open, correct? Stop, it will open, and then
Yes,
any
ma'am.
one port is open. Now, rest of the cases, what you are planning to do also you have to tell me, na? Either in the truth table or in the diagram. Rest of the situations you should tell. Samai, see,
And
automation is.
rest of the situations output will be 0.
That is what you have to explain there, because circuit means what? It's not only half circuit. You have given a half circuit for me and a half truth table. You have to completely analyze all what is happening everywhere, like when all the four inputs are there.
Okay, ma'am. Okay, ma'am. Got it.
Okay, you have elaborated. That's all. Your idea is fine. So only two guys are there. What happened today? Shweta is not there.
Yes, ma'am, I'm there.
What happened, Shweta? No answers today. Yashpal, Vikas, guys are there existing. Samir Ranjan,
Yes, ma'am, I'm here.
you're there. So you people are giving a thought process for that.
Ma'am, my answer was same as some miss.
Like something. Okay. So you are only targeting what should be done when it is open. That's all. Remaining things you are least bothered. But I am a buyer. I need every conditions to be satisfied. Like that you have to explain. So girls, anybody any other ideas?
No, ma'am, I got the same.
Finally, it is the same. Okay, since why it is coming same, because I have fixed the inputs. Had it been in a floating mode, you could have taken your own choices, correct? Because mode control, everything I have fixed it. Like I told, like this has to be done, only 4 inputs. So you will get the same choice. So any other better one? Okay, now I will be dictating, please take down. Another question. A coin detector, because I will not post this. Everybody, please note down. A coin detector in a vending machine. You're taking down?
Yes, ma'am.
Yes, ma'am. Repeat.
And I will try to cut some more and then show you the actual question. Okay. Till here you first note down. Afterwards, I will share you the next part of the question. Quickly note down. Able to see the screen?
Yes, ma'am.
Yeah. Note down. This is a portion of the question. Next portion I will show again. A coin detector in a vending machine accepts quarters, dimes, and nickels and activates the corresponding digital signal Q, D, and only when the correct coin is present. It is physically impossible for multiple coins to be present at the same time. Correct? You have written down?
Yes,
ma'am.
Okay.
Yes.
Then a digital circuit must use the Q, D, and N signals as. Now I'll show you this. Till here, as you have noted down.
Yes, ma'am.
Then next one I'll show you. because in between I had the answer also. After as, right, then as inputs and produce a binary number representing the value of the coin and represent a binary number. Okay, like a VHDL code and all. VHDL code is not required right now, but I can show you the diagram.
Hello, ma'am. Can't see the screen.
I didn't share the screen yet, dear. I'll share now. I am sharing the screen now. Yes, this is the diagram. Okay, here you avoid the HDL and VHDL code. Actually, this is a coding problem, right? So this is the diagram. So logic circuit you have to design, and what exactly the output should be? 5-bit array representing the coin value. You need to think a bit for this one. Okay, I think you have a class, right?
Yes, ma'am.
Yeah, okay. Otherwise, I will post it also. This one, those who have taken it is correct. Okay, please write down. Okay, then otherwise, my time I will post this one. Okay. I'll post the question in night. Right? Okay, ma, Shweta? I think you may join the other class. Next week.
Yes.
Okay.